This experiment is on Poisson's ratio. Our first step is to open any particular test that we have for a tension test experiment. We're manually loading the load on this particular sample so we can use any of the tension test setups. So we can go ahead and zero out the effect of the computational load here. We'll end up zeroing it out a little later just to be sure, but we can zero out any applicable load that may be affected, so we start our test essentially at 0. So we're just checking the controller, making sure we have access to all of the machine components. We'll be able to change the load when we get to that particular section. So our test is a 6061 T6 aluminum dog bone shaped specimen, and we have an axial strain gauge and a transverse strain gauge. The axial strain gauge will measure the strain attributed to the vertical component, and the transverse will be the horizontal component. So we have our P3 strain indicators, and we can set up our system in either a quarter bridge, half bridge, or full bridge setup. In our case, we're doing a one-dimensional tension test, so we'll do a quarter bridge setup. So we take our P3 strain indicator and make sure that all of our applicable channels where we have strain gauges used will have that bridge type, and then we also set the gauge factor, which is specified by the manufacturer based on what strain gauges you're using. So on the strain gauge packaging, it'll say what that gauge factor is. In our case, it's 2.145, and we make sure that both channel 1 and channel 2, which is the two channels that our two strain gauges are plugged into, have that gauge factor shown, which was 2.145. Additionally, we'll measure our length and width of the interior region of our specimen where it's tested. So we want to make sure our calipers are set to 0, and then we'll measure the length and width of our specimen in order to calculate the area attributed to that section of test for our specimen. And once we do that, we'll be able to then calculate axial stress by using force over area, where area will be our length times our width of that center section of our specimen that we're testing. You may have to maneuver around your specimen. You can measure it before it's in the grips. You can measure it after it's in the grips. You can measure in a couple different sections to make sure it's fairly uniform. In this case, we have 0.274 as the value for that region. We're just going to measure it again to see another option, or how if there's any kind of variation in that center section. So here we have 2.2705, and these are both in inches. So once we have that first measurement, we'll reset our calipers to 0 and then measure the other dimension of our interior section of our specimen that we'll be testing. We'll just make sure, reset our calipers to 0, measure the interior section, which is 0.5375 inches. So now that we have the measurements for our test, we want to 0 the strain gauge, or 0 both strain gauges in the strain gauge indicator. So we'll balance, and then it asks if we're sure we want to balance. We press that again, and then once it progresses through the channels that we have strain gauges applied to, it'll say that channel 3 and 4 cannot be balanced because there's no strain gauge readings applicable to those two channels, so then we'll save the settings and that will balance our P3 strain indicator. You may get a residual value that shows up after our first balancing. You can take that into account, or you can rebalance your strain indicator. Here we're rebalancing it. So now we have 0 indication for our readings. Also, our strain gauge readings are measured in microstrain, so the values that you see will be the value times 10 to the minus 6th. So if you see 100, it's 100 times 10 to the minus 6, 1,000 times 10 to the minus 6, and so on. So once we zero the load on the computational setup again, we can now tighten the grip on the top section. So everything we've done previously, the bottom section of the sample is clamped and the top section was not. So now this load that is applied is actual load, so you'll see values that show up as representative strain for those two strain gauges. So in order to get our 0 measurement, we will now decrease the load to 0. And we'll be measuring at 0 pounds, 500 pounds, 1,000 pounds, 1,500 pounds, 2,000 pounds, 2,500 pounds, and then again checking our measurement again at 0. So at 0, our axial gauge is negative 17 and our transverse gauge is 7. So now we'll test 500 pounds. Which is 348 and negative 112, both of which are in microstrain. Now we'll test 1,000 pounds. Which is 722 and negative 233. Now we'll test 1,500 pounds. Which will be 1,101 and negative 355. Our next value will be 2,000 pounds. Which is 1,480 and negative 476. And our last measurement is at 2,500 pounds, and then we'll recheck 0. So for 2,500 pounds, it's 1,861 and negative 598. So our last value will be rechecking our 0. Which is 3 and 0. Again, all of those values are in microstrain.